All right, I'm going to keep just powering on with this. And if you notice, what I've shown you is a way to get the problem back into vertex form. Well, how do we get something in vertex form is to complete the square, which you may remember us doing this in chapter 8 a long time ago. And you may also remember figuring out that you could just do the quadratic formula, and so therefore you didn't really practice completing the square. And I try to give a few of you hints that doing it then, completing the square then, makes chapter 10 easier. And you may remember from chapter 8, that the first thing that you have to do is make sure that the leading coefficient is 1 before completing the square. So all I'm doing, as I mess this up, is I'm factoring out a negative for the first 2 terms. So that's why this changes signs. But I'm not including this plus 6 in that problem. So what I need you to do, and hopefully I can squeeze this all right here, so hopefully you're not writing as large as I am. But the process on completing the squares, we looked at this number, we did half of it, so -4 divided by 2, and we squared that number. So I know some people don't like to rewrite that it's -2 that's being squared, but I think that's helpful, which gives me +4. So just to emphasize, I'm going to change colors and emphasize that I'm putting a +4 right here. Now here's the deal. I'm not really adding 4 into the problem. I have to distribute that negative back in there. So I'm really adding -4 in the problem. Well, that's not okay. You can't just randomly put in a number in a problem unless later you add another number that would cancel it out. So it's really like I'm adding 0 to a problem. So I hope you're in agreement, and if you're not, write down this question and come ask me, that I'm adding -4 here, so later I have to add a +4, so it's really like I'm adding nothing. So now when I go to do this problem, I'm going to switch back to black. What I really have, or just a different color, is I can now rewrite it as this is a perfect square trinomial of x minus 2 times x minus 2, so I can just write it once squared. And that's why I like to write down that number, because it's always the same number that goes right here. And then 6 plus 4 is 10. So now, based off of everything we've learned, first of all, this is an up and down parabola because it's y equals x squared. How is it shifted? It's shifted right 2 up 10. So right 2 up 10. And this negative in front is telling me that it's a downwards parabola. Now, I'm not going to be, what I'm going to grade you on is that you find the correct vertex that does not even look like a parabola. But the vertex needs to be at 2, 10, and I'm going to grade you that it's a downwards. Now, a better teacher would make you get the right y intercept. 1, 2, 3, 4, 5, 6. I try to hit it right there. But this is really all I'll be grading you on, is that. Did you get the right vertex, and did you open up correctly? And this is opening downwards because of the negative. Again, if you have any questions, please write them down. I'm just going to go real quick to Desmos and show you the correct answer. So you can see I just typed it in, and there's no math in Desmos. That's why a lot of teachers will just will not let you use graphing calculators. That's not really my goal right now. My goal is to get you to understand that completing the square is necessary to get this problem. And where's all the work? Well, I showed you the work over here to get to that answer. So let me show you again the process on completing the square. So as I look at this example 4, I'm going to rewrite as x equals. The first thing is your leading coefficient must be 1. So I'm only concerned with the first 2 terms. Remember, I only concerned myself with the first 2 terms last time. And remember, 6 divided by 3 gave me 2. And I left this 4 alone. Well, I guess up here it was 6 I left alone. But that's where I put my spaces. So then I consider this number, 2 divided by 2, squared. Well, 2 divided by 2 is 1. Squared is 1. But technically, I'm not adding a 1 in this problem. I'm adding, as I distribute 3 in there, 3. Well, that's not okay. You can't just add a random number because adding 3 would change the value of it. So that's only okay if later you subtract 3. So why would you go through that process? Is now you can look at this and say, okay, well, 3. Now this is a perfect square trinomial. Factors of 1 that add to be 2 are y plus 1, y plus 1. Well, instead of writing it twice, I can write it once squared. And over here, 4 minus 3 is negative 1. Now remember, this is opening to the right. Okay, right or left because it's x equals y squared. To the right because this term is positive. So where's your vertex at? Well, normally this is backwards of left and right. Well, now it's backwards of up and down. So it's going to be down 1, and this one is to the left 1. Right here. And as I mentioned, it's opening to the right. And I'm not going to concern myself with anything else. I want to see the correct direction and the correct vertex. And negative 1, negative 1. And of course, I'm going to go to Desmos and just point out what that graph looks like. I'll even leave it on here, and you can see how I type it in. 3y squared, except I already forgot what the number was. 6y plus 4. Uh-oh. I must have done something wrong here. And that's why it's good to check your work. Is I should have gone right 1, down 1. Let's see where my mistake was. Oh, here it is. 4 minus 3 is positive 1, not negative 1. So it wasn't even that me reading the graph was fine. The issue is my arithmetic. I added incorrectly. So it's a good thing that I checked my work. There we go. So what will I be grading you on is that you correctly identify that the vertex is at 1, negative 1, and it opens to the right. So I would have lost a point if I was doing this and I didn't check my work. Yeah, I'm going to scroll down just a little bit. And let's change colors and do this one. So again, my first step is to factor out a negative, because this first term needs to be a positive 1. So I'm going to change this one as well to be a positive 4y, because I'm factoring out a negative. Put a blank right there. We've done completing the square a long time ago, and then the last term stays minus 1. By the way, that would be a quick way of figuring out your x-intercept, but anyway. So it's always half of that number squared. Well, half of 4 is 2. Squared is 4. So we're going to add 4 right here. I forgot to write this blank later. But remember, I'm not technically adding 4. I'm adding negative 4 in here. And that's only acceptable if later I add a positive 4. Because remember, you can't just randomly throw in a number. You're changing the value of the equation. So later you have to remove the same value. So why would we go through that process? We have the negative, and this is a perfect square trinomial factored as 2 and 2 to give me 4, but we don't write it twice. We write it once squared, and hopefully I do this correctly. Negative 1 plus 4 is 3. So this is a sideways parabola opening to the left because it's a negative, and remember that vertex is backwards. So the y-coordinate is not up 2 this time, it's down 2, and this is to the right 3. So my vertex, I'll even circle my vertex this time right there, is right 3, down 2, And if I was being a stickler, I would make you point out that the x-intercept is -1 right there, but I'll let you get by with just opening up to the left because of the -a value right there. And this stuff is not easy. So if you have a question, please write it down and bring it to class. That way I can hopefully answer it. And as promised, I'll go to Desmos and just point out -y squared. I already forgot what it was. -4y minus 1. And I know my graphs get busy, so if you ever want to just not see a graph anymore, just click on this side so you don't have to completely erase it. And you can see some of the points that I mentioned. By the way, you can also make this, turn it into, apparently you cannot turn this into a table because it's not a function. I guess you can only see the tables on Desmos if it's a function. But if you click on the graph, you can actually move around and see what the ordered pairs would be if you really wanted to. But all I care about is the vertex and what direction you're opening. There we go. And that's probably a good place to stop because the next section is all about circles. So just kind of a heads up that I'm going to make another video and hopefully I can get the rest of it done within the next video. But like I said, this is a long section, a lot of notes to take before you're ready for that homework.